The affected packages are some of the most downloaded on NPM, with Flatcache alone pulling in over 565 million downloads a month. The worm was designed to steal credentials, which could have massive ripple effects across the JavaScript ecosystem. If you're a Node.js developer, there's a real chance you're using one of these packages indirectly. This isn't a theoretical vulnerability, it's a live attack on the software supply chain. A game is increasingly tied to the health of a server somewhere. This is a wake-up call about digital ownership. If a console can brick your disk games during an outage, what's the point of buying physical? It also puts pressure on companies like Microsoft to ensure their services are rock solid because they're now the gatekeepers of our libraries. If you're a gamer, maybe think about what ownership means to you. And if you're a developer, consider how your services can fail gracefully. This is a lesson in resilience. DeepSeek V4 Flash on a single AMD MI300X. A developer shared a production-ready setup for running DeepSeek V4 Flash on a single AMD MI300X GPU. They pinned specific versions of VLLM and Aider and included patches to fix issues with FP8 format, MOE routing, and kernel shapes. The result? The model runs as shipped, without quantization or offload on just one card. The official VLM recipe targets NVIDIA and newer AMD hardware, so getting it working on MI300X took some serious engineering. The developer documented all the fixes and made them public, which is a goldmine for anyone trying to run large models on AMD. This is a big deal because AMD GPUs are often more affordable and available than their NVIDIA counterparts. This could democratize access to large language models. If you can run a model like DeepSeek V4 on a single AMD card, you don't need a multi-GPU cluster or a cloud provider. It's a step toward running serious AI on open hardware, which could save companies a ton of money and give them more control. Smaller, faster, safer, running Kimi and GLM at scale. Cloudflare's Workers AI team published a deep dive on how they serve large MOE models like Kimi and GLM efficiently. They use 3 techniques: quantizing the KV cache, compressing model weights, and separating prefill and decode phases. This lets them fit these memory-hungry models into GPUs and keep them fast. This is a follow-up to their earlier work on serving large models. The challenge with MOE models is that they're huge, but only a fraction of the weights are used per token. By quantizing and compressing, they can serve more users on the same hardware, which is crucial for a platform like Workers AI that runs inference close to users. This is about making AI inference cheaper and more accessible. If Cloudflare can serve these models efficiently, it means developers can build apps with state-of-the-art AI without breaking the bank. It also shows how clever engineering can push the limits of what's possible on existing infrastructure. That's all for today. If you want to stay ahead of the curve on AI and tech, hit that subscribe button. We'll see you next time.